just wanted to touch base with you on
Yeah.
how you are going about trying for this.
I know. I mean, I see. I'm not a good example for you guys, but anyway, we can talk. Hey, hi.
Yeah, yeah. Can you just ping me your
Yeah.
phone number?
Yeah. Sure.
I'll just touch base. Thanks.
Not a problem.
Hey, hello everyone. Good morning.
Good morning, Shiva.
Hey, Shiva, morning.
Yeah. Let me get started.
Yes.
Hemant, you were there. Were you there yesterday?
Yes, I was there yesterday. Maybe towards the end, middle somewhere. I just stepped out, but I came again towards the end.
Okay.
Did you ask for me?
No, I was just checking whether you are following up or not.
No, I was.
Okay. So let me share my screen. So yesterday we have seen the basic introduction. Let me.
Bathroom huh?
Shiva, this is funny.
Hey, hi, Funny. Sorry, I muted you. Yeah, can you tell me?
No, okay, thanks. So I missed all of these like the previous classes. So the videos, I don't know where you told that you already shared on the drive, right?
Yeah.
Can you just link? I don't seem to have it.
Okay, let me share it with you right away. Otherwise, I will forget.
Sure. Thank you.
Also, please, it's my sincere request that sometimes when I upload the videos, so I will show the real clusters as well. So you should not upload any of these videos anywhere in the public sites. Okay. So public sites in sense YouTube or any other publicly accessible places, because that is, that puts my job in risk. Okay. I hope everybody is matured enough to understand that. Okay. So this is for your understanding. I might show sometimes the real clusters and real things. Okay. So I hope everybody stick to that. And you sharing with your friends and they're sharing somewhere in public sites. Okay. We'll call you after session. Yeah, sure, Satish. No problem. Okay. Yeah, please take it it as my sincere request. I understand your what I was trying to do. I think I have two Gmail IDs for you, Funny. Might be I might have given you for some other. Funny Piata. I have two. So it's the first one, right? Okay. Yeah. Now you should be there, of course. So Hemant is having access. Neetu Gupta, Murli, Anand, Swaroop, Narendra, Lakshman, Hasita, Soumya, Akira, Funny, Igatwala. Swaroop, you have two email IDs. Srinivas, yep. Yeah, I think I missed your email ID, Funny. Yeah, it's my fault. Okay. So could you also please share me? Okay. Okay, Satish. Let me talk to you once again. Yeah, I will share it with you, not a problem. Okay. get started with this. So yesterday we have seen just the workflow of Mapreduce. Okay, so how does input will get into splitting, and then map phase, and then shuffle phase, okay, and then reduce phase, and final output. Okay, and the high level, how does the job get submitted? So client to Yarn resource manager, from there to node manager, inside that containers, and inside the containers map or reduce tasks. Okay, so they will get executed and the results will be sent back in the same order. Okay, so in between there is one more component that comes in picture, application master, but let me defer that for now. Let me put that aside for now. Okay, so once after we go through the coding part of at least first Mapreduce program, so whatever the algorithm that we have seen yesterday for word count, so that is the simplest one. That's why we take that as an example. So once we learn that, so I will try to give you a few more examples around that. So as I was telling, for input and for splitting, we don't need to do any coding, only for map and reduce phases. So for these two phases, we need to worry about in our development side. Okay, so in order to write these Mapreduce programs, so Mapreduce Framework itself has given us some generic classes for us. So they are like arc.apache.hadoop.mapreduce. Okay, mapper class. So this is one class that is given by the Mapreduce framework or the Hadoop framework. And for reducer, we have the reducer class. And so these two are the main important components of your Mapreduce shop. And in order to trigger them, you should have so these are classes, and you should have your driver working space, as I was showing you, right? So in our Java classes also, where we have seen parent classes, subclasses, and I used to run one execution class where I will declare my main method, and from that main method I used to call them. So to have that main method and call these mappers and reducers in the sequence, or to specify what is my mapper class, what is my reducer class, so we should have a driver class as well. Okay, so this class name can be of anything, and yeah, you can even create this class without extending any other classes as well. But any of your custom class, custom mapper or custom reducer that we write, so we should extend this mapper class for our custom mapper class, and we should extend this reducer class for our custom reducer class. So by default, the mapper class that is provided by Hadoop and the reducer class that is provided by Hadoop, they just take the input as it is and they produce the output as it is. So these are like identity functions. So they call as identity mapper also, and identity reducer. Okay, so the default mapper and default reducer classes, they will take the input record and they write it as it is. Okay, but in any of our Mapreduce processing, that is not the intention that we need. Okay, we don't need to just copy and paste as it is. We will be processing the data for some purpose. So in our examples, we were seeing that we need to parse the records. We need to take line by line, and we were parsing that line into words by space delimited. Then we are counting those words, right? So let's code the same stuff. And before coding that, let's understand. So how does the basic skeleton of mapper class and reducer classes looks like, provided by the Hadoop framework. Okay, so let's understand this. So let that get loaded anyway. So in our mapper class, mainly you will find 4 methods. So one is setup method, and one is map method. So it expects key K1, value V1, and context object. Okay. And after that, you will have a cleanup method. So inside my mapper class, so these are the methods that you will see, and you will have a run method. So in this run method, this is how the logic will be like. Setup method, it's called the setup method, and for loop key value pair, for every key value pair, map of K1, V1, let's say context. Okay. So after that, so this explains, this skeleton body will explain you. So how does this will get executed? Okay. And similarly, the reducer class as well. Same like your mapper class, but instead of map method, map method here, so it will have reduce method, and the parameters types, they differ bit. And yeah, same like for loop here in the mapper class, you will have for loop even in reducer class, and the reduce method will be called inside that for loop. Now, whenever you want to execute the mapper, so the first method that it executes is the run method. So the control comes to a run method, So inside this run method, if you see this, we have a call to setup method. So whatever is present in this setup method, this will get executed once, right? Since we have call to this setup method. So this method will get executed once. Now, since my Mapreduce framework expects key comma value pairs, it sends that first key value pair, or it loops through all the key value pairs, and for every one key value pair, it calls this map method by passing that key and value and this context object. So here the context object is used for writing your text in the serialized format onto your intermediate storage or intermediate output files. So via this context object, it writes that into intermediate files. Okay. So now, so that means if you have 100 key value pairs in the input, so this map method will get called 100 times, so looping through this for loop. And after completion of all the 100 key value pairs, so you are calling the cleanup method. And even this method will get called only once. So now I can rephrase my statements like, so setup method is like a initialization stuff, initialization work that you want to do before processing your key value pairs, and cleanup method for post processing or closure activities. If you want to, after processing all your key value pairs, then if you want to perform any actions, then this cleanup method will be useful. Okay, so generally, most of the times, in at least 80%, 80 to 90% of your Mapreduce programs, you don't see the implementation for your cleanup and setup methods in your custom Mapreduce programs, in your custom mappers. So 80% of the cases will override only the map method. So we leave the setup method and cleanup method as is. We'll just override the map method. That's it. We will leave setup method, we'll leave cleanup method, and we'll leave run method as it is. So that means setup method will be called once, and cleanup method will be called once after processing all the keys. And how does your key value pairs needs to be processed inside the map method? That's the only part that we will write in our Mapreduce programs. And remaining all other code, the default logic is sufficient in most of the scenarios. So now you have to remember this skeleton. Okay, so if you want to write any advanced Mapreduce program, changing anywhere, so this skeleton is more than sufficient. Keeping. But if you want to write any typical ones, like that falls under that 80% scenarios, then remembering the mapper class and the map method inside that is sufficient. Now, let's write our mapper methods, our mapper class, to process our word count example. Okay, so for that, I will write my class word count mapper. We should extend the the basic mapper classes and reducer classes that are received from the Hadoop framework. Because we might not provide the implementations for all other methods, we can reuse all these functionalities, right? Setup, cleanup, and run methods, all this stuff. Okay. So word count mapper extends mapper, and here we should specify our key value pairs, input key value pair data types. So what are the data types that you will receive as a key value pairs? And when we talk about the text files, if you are processing any of your text files, any text file format, then your line numbers, ideally speaking, line offset. Okay, so ideally speaking, it's offset. So byte offset, or for your easy understanding, you can take that as line number as key and the line text as value. So, for example, if I have big data is emerging and Hadoop is one of the tools used to process the big data. Okay, so Spark is another processing framework to deal with big data. Okay, now let's assume you have these three lines in your one of the text file. Okay, so now if you take that in terms of these key value pairs, let's assume this as 1 comma 1 is a key and big data is emerging is a value for the first record. Okay, so this will be treated like this. And here, so for the second record, so how many bytes are there? So 4, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 21. 21 is the byte offset. So 21 comma this. And again, let's assume you have another 60 or 70. Okay. So then 60 plus, it might be around 50. So 50 plus 21, so which will come from 71. Let's assume. So this is the key for first line, and this is the value. And the second line, this is the key, and this is the value. And for third line, this is the key, and this is the value. So here, line offset or byte offset, which is nothing but a number. And in case if you are taking some huge files, so this will be very big number, right? For big numbers, in our Java terminologies, we can specify the long. Okay. And so this is nothing but a string. Okay. And so inside your mapper class, what do you want to do? So you will parse this records, take this as one record, and take the text out of it, only the value part of it, and delimit that by space, and collect these words into an array, and associate a count of integer count of 1 for each of these words. And so your output, expected output for this from your mapper class is big comma 1. So even your output will be in key value base, comma data comma 1 comma is comma 1 comma emerging comma 1. Right? So if you are expecting this type of output, so you should specify the output key value pair data types as well. So your output key is of string type and value is of integer type. But here, coming to the Mapreduce framework, instead of using the Java data types as it is, we have Mapreduce owned, Mapreduce specific data types. Okay, so those are like for Java integer. So let's assume the data types inside Java. These are the data types, and let me list down them for Mapreduce. Their corresponding Mapreduce data types are. And why we need to go for that, we'll see that sometime later. We have int writable. For long, we have long writable. For double, we have double writable. For Boolean, we have Boolean writable. And for string, we don't have string writable, but we have text. Even this is not text writable, it's just the text data type. Okay, so we don't use the Java data types as it is in the Mapreduce. We use its corresponding counterparts in Mapreduce, like for int writable, for long writable, for double writable, and for string text. Okay, so why we need a separate data types in Mapreduce framework? That is out of scope for today. Okay, we'll see that sometime later. Now, keeping this in mind, so long, replacing long with the long writable. This is my Mapreduce program, and string with text, and again this string with text, and this int with int writable. So now my first line is completed. My first line of code is completed. So I'm just extending the mapper class, specify the long writable as key, input key, and text as input value, and text comma input int writable as output key and value data types. Okay.
Shiva.
Yes, Anand.
Shiva, I want to interrupt you for a couple minutes. So again, the context, if you can help a little bit. So we have an input string, and we want to map reduce that string, meaning that we have a data. Like, what do you have this like 1, 21, 71? What exactly is that?
So here, I showed you this as my line data inside my file, right? So this is first record, and this is second record. Okay. So in my input text file, this is my first record, and in my input text file, this is the second record, and this is my third record, third line of input. So this is my input text, input.txt file, let's assume. So I want to process this file and generate the counts of each of these words. So that is the context here. The same, yesterday we have seen that word count workflow, right? So for that, since your Mapreduce framework expects everything as key value pairs, whether it is input or output, it expects everything in the key value pairs only. So for that reason, since you don't have key value pairs here, for any text files, your line offset is treated as a key, and the actual text of that line is treated as the value. So here, for first record, one is the byte offset or line offset. And for second line, so how many bytes are there? 20 bytes are there in this. So 21st byte is the offset for this record. And how many? So 50 bytes are there in this line. So 21 plus 50, 71 is the offset for the next line.
And that full text becomes the key, right? Like big data is emerging.
Full text is the value. Full text is the value. One is the key.
One is the key. So it goes by the byte. Every incremental byte is a key then.
Yep. So this is the key, and this is the value.
And now we want to map those. Is that what it is? We want to map this.
So I mapped 21 with the long readable and Hadoop as text. And once we process, we should generate something like this. So every word, comma, its associated count of 1.
So every word gets associated a key, every word in that text?
Yeah. So now in my output, big is the key and 1 is the value. And data is the key and 1 is the value. Easy is key and 1 is value. Emerging is key and this is value. From map output. This is input for map. If you take only one record, this is the input record for map, and this is the output from map.
Now, who will determine the key? Will the code automatically determine the key, or as a developer?
We are declaring it here. Okay. So in any text files, the input key is determined automatically. Input key and input value is determined for all text files.
Your Shiva writable is an interface, right?
Let's not talk about that. I will defer that later. It's a data type. Assume it is a data type. I think network got disconnected. Mobile Tangkaya. Dari iPad